Hello and welcome. Today I want to talk to you about acids and bases. And what acids and bases are, they're basically categories that we can put chemicals into according to how they behave. Not everything is going to qualify as an acid or a base. So pH is another way of referring to this. pH is a unit of measurement that is going to analyze or I guess dictate or describe how a chemical is going to react based upon those properties. So some examples of acids. Lemon juice is an acid. Your stomach acid that you have in your body, that's an acid as well. One thing you're going to notice about acids is that when you look at the chemical compound, many of these are going to begin with hydrogen in their chemical formula. And so we have different types. Just some examples here. We have nitric acid, HNO3, hydrochloric acid, that's your stomach acid. Again, they all like to begin with H in their chemical formula. Some properties of these, if you can taste it, if it's okay to taste, it's going to taste kind of sour to you if you put it in your mouth. Now, looking at the pH number, remember that 7 is neutral. So anything that has a pH of less than 7 is going to be qualified as an acid. Something else is that when we use indicators, it's always going to turn blue litmus paper red, and other indicators are also going to be affected by an acid. By contrast, if we look at bases, the first thing I want you to see is that these bases are going to end with OH, which is a polyatomic ion that has a -1 charge. So you'll usually see a metal with OH at the end. Again, that's a polyatomic ion. So what we have there is we have oxygen, which has 6 valence electrons, bonded with 1 hydrogen, which has 1 valence electron. So there's still a -1 charge it has, and it gets that +1 from the metal to form that bond. But again, remember that acids are going to begin with H, and bases are going to end with OH. Some qualities is that, first of all, these are going to have a bitter taste to them. If you are able to taste them, some you would not want to put in your mouth, obviously. And the pH is always going to be higher than 7. So a high pH is going to be a base, whereas a very low pH is an acid. These are going to turn red paper, the red litmus paper is going to become blue. So just looking at some indicators real quick, let me get my safety goggles on. So here I have a few chemicals. Let me turn this off. And by the way, most of your soaps are usually going to be a base as well. But I have 2 different kinds of paper here. I have the blue paper, and it's kind of a purplish color, not exactly blue. And if I take the blue paper and I put it into a base, let me show you what happens. So here I have some sodium hydroxide. I'm going to put the blue paper in, and nothing happens. If I get that closer, you'll see there's no color change. If I take the blue paper, and I got to be really careful here, and I put that blue paper in hydrochloric acid, this is your stomach acid, being very careful, you'll see it kind of has a pink color to it. Let me get that closer to the camera. Okay, so not exactly a dark red, but a kind of a pink color. All right. Now another kind of paper we have is a red paper. Let me show you what happens if I put the red paper in the hydrochloric acid and then the sodium hydroxide. So you separate this. All right. So here's hydrochloric acid. You can see the formula HCl. Starts with an H. It's an acid. So I'm going to put it in there. You see there's no difference. Okay? Not really a color change. It just got wet. If I take the same paper and I put that in with the sodium hydroxide, Again, being very careful. Sodium hydroxide, this is the active ingredient in Drano, or drain cleaner. You'll see that it has that that blue color on the red paper. Now, what I like to do to remember this is I remember that the word base and the word blue both begin with a B. And so that can kind of help you. This little mnemonic device that can help you remember that bases are blue and acids are red. But something else, another indicator, is we have a substance called phenolphthalein, which is the active ingredient in many laxatives, ironically enough. So here's my hydrochloric acid, stomach acid. I'm going to drop some of the phenolphthalein in there, and you'll see that nothing really happens. There's not really any kind of indication that anything is present. But if I do the same thing to the sodium hydroxide, and you don't want to get this stuff on your skin, by the way, it can burn you just as much as acid can. But you'll see that there is a color change there. And again, that's an indicator to show the presence of a base. Now, one thing you need to be aware of is a neutralization. So here I have my sodium hydroxide, which has been added to the indicator, so you can see that purple color there. If I add the acid to that, let me back up a little bit. You can see that it kind of goes away. And the reason is, and there's still some like little specks in there if you want to kind of look. But the reason that happens is because, you know, acids and bases are opposites. And so if you add an acid to a base, then they're going to neutralize and they're going to become neutral. So looking at what we're talking about here, if I have an acid, that's going to be very low on the pH scale. Here is 7, and then down here we're going to have something that's like less than 7, and up here something greater than 7. So 7 is neutral, and that's going to be like water and other things like that. Usually your skin has a natural pH of around 7, and then above 7 you're going to have a base. Okay, so again, something like stomach acid will be down here. Something like soap or baking soda would be up here. So that's just and by the way, you know, some of these are foods that you can eat. They're safe to eat. If it has a sour taste, it's going to be down here. If it has a bitter taste, it's up here. If it feels kind of oily or slippery, it's going to be up here too. So these are most of your soaps and detergents. These are a lot of the foods you like, soda, coffee. That's going to be acidic. But this is just a brief introduction to acids and bases, and we'll do more in the classroom. Thank you.